All right, so section 3.6 is about some unusual patterns that we need to find with factoring. And one of those patterns is called the difference of cubes. Now, that means you have two things that are perfect cubes. We'll just use A and B as an example, and we're subtracting them. So the pattern looks like this. Well, first we have a linear factor, and that's A minus B. So it literally looks like I took the cube root and the cube root of each one of those, which I did. And then the exact same sign in the middle. Because this could be used for a sum of cubes also, but we'll talk about that in a minute. But then it's got to be multiplied by something which is a non-factorable quadratic. So I literally take the first term and I square it. And I do the same thing with the last one, square it. Then I multiply them together. And take the opposite sign. So if it was a minus in the first parenthesis, it is now a plus. This exact same thing is going to be done when we get to a sum of cubes. Except the first sign in the linear term will be a plus, and the middle term on the second one will be a minus. But exactly the same thing will happen. So I literally need to think about cube root, so I can get the first two, which would be x minus 2, right? Cube root of x cubed, cube root of 8. Same sign in between. Square the first, square the last, multiply them together, take the opposite sign. That's as hard as it gets, folks. Or practice. So cube root of that would be 5x, and the cube root of 64 would be 4. Same sign. Square it. Square it. Multiply it together and then take the opposite side. I can't even multiply, can I? Multiply them together, you get 20x. Why did I double it? I don't know. Cube root, cube root. So we got an x and a minus 3. Square it. Square it. Multiply them together and take the opposite sign. So does the same pattern happen with these? It sure does. Cube root, cube root. So we have x plus 2. Sign always matches the first on the linear one. Square that one. Square that one. Multiply them together and take the opposite sign. Cube root, cube root. Six x. I think 9 square the first one, square the last one, multiply them together and take the opposite side. Cube root, square it, multiply them together, take the opposite side. It just happens over and over and over again. Well, what if these sum of cubes or difference of cubes were set equal to 0 and we were supposed to solve? Well, we know there are 3 answers to this question because it's the third degree. So let's do what we did before. Cube root, x plus 7 x squared 49 minus 7x. We always know that we have to set our factors equal to 0 and solve them. Well, how do we solve? Well, the first one's easy, right? X equals -7. Second one, not so easy. Let's see if it factors. We'll use our discriminant from our quadratic formula to see if it factors. That number is not on the top of my head. Hold on. It appears that we are getting -147 for that value. Well, that's definitely telling me we're going to have imaginary numbers. We might as well finish the rest of the quadratic formula. Opposite of b over 2 times a. Plus 1 minus square root -147 over 2 times 1. Now that square root -147, that can be broken down, right? It's going to break down into -49 and 3. Always looking for perfect squares which go into those numbers. So we really have 7 over 2 plus or minus 7i radical 3 all over 2. So the first solution, easy. Second solution, more difficult. Or second and third, I guess. Because they come as a pair. Let's do another one. So cube root, same sign. Square the first term, square the last term. Multiply them together, take the opposite sign. it is set equal to 0, so we set the factors equal to 0, x minus 4, so that means x equals 4. One of my answers. And we can go straight to the quadratic formula here, b squared minus 4 times the a value times the c value. That is negative 48. So, opposite of b over 2 times a plus or minus square root, let's see, negative 48 can be broken up into negative 16 and 3 left over. So, negative 16, 3 all over 2 times 1. So we can simplify this first one down to negative 2. This thing right here is 8i. No, 4i. That can be reduced with the denominator to 2i. So, those are your other two answers. So, cube root. 8x plus 3. Square the first one. Square the last one. Multiply them and get that together and take the opposite sign. Okay. Set the first one equal to 0. Tad bit more work than normal. Negative 3 over 8. B squared minus 4 times the c value. Let's go figure out what that is. So this ended up giving me negative 1,728. And the largest perfect square that I found that went in is 576. So as I continue my quadratic formula, opposite of b over 2 times 64 plus or minus instead of square root negative 1,728, I'm just going to write square root negative 576 and 3 left over. So let's see here. 24 divided by 168 or 128.1875, that is 3/16 plus or minus. That's going to be 3i radical 3 over 16. And that's the notes for that particular section.